Hello everyone. So in today's session, we are going to talk about the wonderful concept of Mohr Circle. And my dear, if you are related to the field of mechanical and civil, you would definitely be aware of this name, the wonderful concept of Mohr Circle. So guys, I will be telling you each and everything A to Z related to the Mohr Circle. And after this session, it may become very, you can say, easy for you, and also you will become master of this wonderful concept because we will see this concept with the eyes of Mohr. So guys, we are moving further. Before we start the session, this is some detail about me. My name is Dheeraj Sardana. I am having around 10 plus years of experience, and this topic is related to the strength of materials. So before we start the topic, let's talk about the person who have given this wonderful concept. So guys, by looking at this, every civil engineer should feel proud because he was a German civil engineer, Christian Otto Mohr, who have given this wonderful concept of Mohr Circle. He is famously known for this. Otherwise, he have given a lot of contribution in the field of structures as well as strength of material. If you want to know what are the other things you are familiar with and was related to this person, so I would like to say there is a Mohr theory of failure. Okay, there is a Mohr's theory of failure which was given by Mohr. Other than that, you must have studied deflection topic. So in the deflection topic, Mohr moment area method. Mohr moment area method to find out the slope and deflection is one of the other thing which is related to this person. And other than that, in the structures, in the trusses topic, you have seen Williott-Mohr diagram. That is also related to this person. So guys, this is wonderful contribution of this wonderful person, civil engineer, Sir Christian Otto Mohr. So now giving a lot of regards to him, we are starting the session, my dear. First of all, I would like to tell you how Mohr get an idea that these dangerous looking equations can be shown by a wonderful small circle. So my dear, he got this idea because generally all the mechanical engineers, civil engineer, whatever you see engineering is, first of all, it is said to be the basic step is maths. Mathematics is the first step, second is physics, and third is mechanical or civil engineering. So my dear, they were all good in mathematics, and by looking at the equation, they get an idea that yes, a circle can be used for the purpose. For your purpose, I will be, you can say, simplifying the things for you. Like if you see this equation, and if I will be just modifying it, and I will write it as sigma theta minus sigma xx plus sigma yy by 2. And on the right hand side, we will be having sigma xx minus sigma yy by 2 cos 2 theta plus tau xy sin 2 theta. This is equation number 1. And then I will choose this equation and I will write it as tau theta minus 0 is equals to sigma xx minus sigma yy by 2 sin 2 theta and minus tau xy cos 2 theta. If you see these two equations, if you are just squaring and adding these two equations, just squaring and adding, then my dear, squaring and adding will give you the equation in the form of as sigma theta minus sigma xx plus sigma yy by 2. You know as it is, the left hand side, you have squared it plus tau theta minus 0 ka square, and you will be getting right hand side as sigma xx minus sigma yy by 2 ka square plus tau xy ka square. So my dear, if you see this equation, it looks similar to x minus a ka square plus y minus b ka square is equals to r ka square, which represent the equation of a circle. And when you will get the equation of a circle, you know a comma b is representing the center and r is the radius. So my dear, if you see here, center point for this circle will be coming like this. You know a is sigma xx plus sigma yy by 2 comma 0, because you know with the tau theta we have 0. And if you are going to talk about the radius, this term is the square of the radius. So my dear, based on that, you can also write the radius will be given as equals to square root of, it is sigma xx minus sigma yy by 2 ka square plus tau xy ka whole square. So from that you can get an idea why a circle would be the best geometry to represent all those things which you are doing with these lengthy equations in analytical method. So guys, I would also like to add, if you see the coordinate of center, you can see these are the generalized expressions. It means any Mohr circle, when it will be plotted, will be having center on the x-axis, because permanently y is 0 on the x-axis. So you will see in many of the papers like engineering services, GATE, HPCL, HAL, you will find a question where they plot 4 circles and they ask which one is correct. Even in GATE 2023 the same question was asked. So you know only that circle will be a correct one which will be having the center on the x-axis. So guys, this is about the introduction to the Mohr circle. So as I already told you, it is the wonderful graphical method which is used to find out the principal stresses and strain, which a special coordinate system was defined. So for plotting the Mohr circle, Mohr have defined a wonderful coordinate system, and he have taken normal stresses on the x-axis, shear stresses on the y-axis. So he have taken that positive x-axis, he will be taking the normal stress positive or tensile. Negative x-axis for normal stress compressive. Positive y-axis for shear stress clockwise, and negative y-axis for shear stress anti-clockwise. This was the coordinate system taken by Mohr. Now we will see how a Mohr circle will be plotted for the most dangerous loading condition, which is the combined loading. You can see this shows the state of stress at a point. We already have discussed that stresses are defined at a point. Okay, and if you remember state of stress at a point we are talking about, if you remember, we have also seen how we will be writing the stress at a point in the form of a tensor quantity. So if you see this is as a state of stress at a point, then my dear, you can see here normal and shear both are acting. So this type of loading condition is said to be the combined loading. So my dear, now we will go step by step that how to plot the Mohr circle. For plotting the Mohr circle, the first step says write down the state of stress on the x phase and y phase in the terms of the Mohr coordinate system. As per the Mohr, x-axis contains of normal stress, y-axis contains of shear stress. So according to that, this is the x phase. What do you mean by x phase? X phase is the plane which is perpendicular to the x-axis. So if you are taking in this direction x, in this direction y, then my dear, this phase is said to be the x phase. This AB phase is said to be the x phase. So on this phase, normal stress is sigma xx, shear stress is tau xy. You can see normal stress is tensile and shear stress is going to rotate the element in anti-clockwise direction. We have considered tensile as positive and shear clockwise as positive, anti-clockwise as negative. So this is going to be the state of stress at x phase. We will be denoting it with a point A. Now we will talk about the state of stress at y phase. You know the phase which is perpendicular to y-axis is said to be the y phase. And on this y phase, you can see normal stress is sigma yy, shear stress is tau yx. You know tau xy, tau yx are equal in magnitude but opposite in direction. So here I will be writing plus sigma yy and plus tau xy, because tau xy, yx are equal. This point I will be denoting by B. Now if we want to plot the Mohr circle, the next step says show these points on the coordinate system of Mohr. So my dear, if I will be plotting this on the coordinate system of Mohr, you know this point A will be coming somewhere here. I am assuming sigma xx will be more than sigma yy. You can ask me, sir, but why? Dear, this is our assumption because in the real case, when you will be given the values, by looking at the value, you will get an idea that which one is bigger. So here I am taking sigma xx is more than sigma yy. So this point will be representing sigma xx on x-axis and tau xy on y-axis. Similarly, we will be moving to point B, and that point B will be coming somewhere here. Height will be equal because you know tau xy and tau yx are equal in magnitude but opposite in direction. And sigma yy will be this. So this point is B. Okay. So next step is to show these points on the Mohr coordinate system. Then I am coming to step number 3. Step number 3 says join AB. Join AB. And you already know that center of Mohr circle will be coming on the origin. Here I am confirming that point will be the intersection of this AB with the x-axis. Or you can see where AB cuts the x-axis, I will be taking this point as the center. Now taking C as center, AB as diameter, we will be plotting a circle. We will be plotting a circle, and that circle is nothing but the Mohr circle. So my dear, I feel this is the Mohr circle with the eyes of Mohr. I have told you this circle, if you see how to plot it, many you can say dangerous ways or lengthy procedures are mentioned in the books. But I feel from today onward, if you learn it, you can make Mohr circle for any case. Now my dear, if I do not tell you what is the significance of Mohr circle, that what Mohr circle tells us, then the lecture will be not completed. So to complete this lecture, maybe takes some more time, but I would like to give you the entire idea of the concept, that what are the things this circle is telling us. So let us see one by one those wonderful points. We already have seen the procedure for Mohr circle, so no need to repeat for that. Now let us see the first very important observation, or you can say the significance. For this Mohr circle, the first point is about center and radius. We already have derived for this, but once again, if you want to write with the geometry, then you know this point is sigma xx, okay, and this point is sigma yy, that we already know, okay. So my dear, the difference between these two will be sigma xx minus sigma yy. So this can be written as sigma xx minus sigma yy. By symmetry, this will be half of this. So if I want to write down the sigma star, which is the coordinate of center, so my dear, sigma star can be written as, this is sigma yy plus this is sigma yy plus half of this distance, this. So I can write it as sigma xx minus sigma yy by 2. So you will be getting sigma star as sigma xx plus sigma yy. You already know this is going to be the point on the x-axis. Now my dear, if you apply the Pythagoras for triangle BCD, you know you can find out the radius as well. So radius will be given as, you can see Pythagoras theorem. You will be applying it. You can see this ka square plus this ka square. So sigma xx minus sigma yy by 2 ka square plus tau xy ka square. This will give us the radius of the Mohr circle. So my dear, after getting this first observation or significance is over, let us move to the second one. Now my dear, what Mohr circle is representing? You already have seen this point A was having a coordinate of sigma xx comma plus tau xy. And you said this shows you the state of stress on x phase. And what is x phase? It was a plane perpendicular to x axis. Similarly, point B represents the state of stress on y phase, that is sigma yy comma tau yx. You know this is minus and this is plus. So my dear, what is B? B is the state of stress on y phase. What is y phase? A plane perpendicular to y axis. So from here we can see that every point on this Mohr circle, like if you take this point, will be showing the state of stress, at some of the plane. And my dear, to represent that plane, we will join a radius with that point from the center. So that radius will show the plane, and this point will show the state of stress on that plane. Okay, so my dear, what do you mean by that? It simply means if we are going to take a point, a plane here. So on this plane there will be some normal stress, there will be some shear stress. So that normal stress and shear stress will be represented by some of the point on the Mohr circle like this, and center to that point radius will tell you about that plane. So every point on Mohr circle shows the state of stress, every radius shows that plane. So my dear, this is what Mohr circle is representing. The third thing is, you know that in reality this was the x phase, in reality this was the y phase. The angle between x phase and y phase was 90 degree. But my dear, if you see here, your CA was showing the x phase and your CB was showing the y phase. So if you see carefully, the angle between x and y phase here is 180 degree. So if that angle is 180 degree, it means Mohr just doubles the angles. Mohr circle just doubles the angle. It means if you want to show a plane which is at an angle of theta anti-clockwise from the x phase, so how it will be plotted here? Here it will be plotted at an angle of 2 theta anti-clockwise from the x phase. So angle is becoming double, but directions remain the same. So this is a wonderful point related to the Mohr circle. Then my dear, we are moving to the fourth and very important point. We already know that there is a something called as principal plane. So my dear, there are some famous planes in the study of you can say strength of material, because these are the planes on which shear stresses are zero. You know, Mohr represented shear stresses on the y-axis. So my dear, you know that y will be 0 on the x-axis. So Mohr circle will cut the x-axis at this point and at this point. So this Mohr circle is cutting the x-axis at these 2 points. So it means these 2 points gives us the state of stress at the principal plane. And the radius joining these points will represent the principal plane. So you can say CP1 and CP2, they are 2 principal planes. And my dear, you can see the angle between these 2 principal planes is 180 degree. But you already know Mohr circle doubles the angle. So in reality, 2 principal planes, principal plane 1 and principal plane 2, they will be at an angle of 90 degrees. They will be at an angle of 90 degrees. So if principal planes we are defining, they are at an angle of 90 degrees. You can also find out the values. You know already the center coordinate was sigma star. If I add radius into sigma star, I will get sigma 1. If I subtract radius, I will get sigma 2. So you can write sigma 1 as sigma star plus radius, and you know sigma 2 as sigma star minus radius. You know the value of sigma star, you know the value of radius, you got the wonderful principal stresses. So you got those dangerous expressions that sigma 1 comma 2 is written as xx, yes, xx, okay, xx plus yy divided by 2 plus minus square root of xx minus yy by 2 ka square plus tau xy ka whole square. So guys, you can also see one more thing, like this distance, the diameter of the Mohr circle can be written as sigma 1 minus sigma 2. So radius can be written as sigma 1 minus sigma 2 by 2. So one more expression for the radius we got from here. So guys, moving further to the next point. So we already have seen principal planes are at an angle of 90 degrees to each other. Now it's time to see about the shear stresses. We already have seen principal planes are plane where shear is 0. If you will find out the value of sigma 1 and 2, you will get one more point, that sigma 1 is the maximum normal stress possible and sigma 2 is the minimum normal stress possible. Means, as you know, we can make infinite planes. Here, if you will be changing the value of theta, you can make infinite planes. For infinite planes, we will be having infinite value of normal stresses. Out of all those infinite values, the maximum possible normal stress will be sigma 1 and the minimum possible normal stress will be sigma 2. Means normal stress at any plane will lie between these two values only. So this was the wonderful point I wanted to give you. Moving to the plane of maximum shear. You know, shear is represented on the y-axis. So my dear, if you want to have plane of maximum shear, if I will be making the vertical lines from the x-axis, you can see vertical lines up to the Mohr circle I am plotting. If I will see all the vertical lines, I feel everybody is aware and can understand that the line which I am going to plot from the center, that is nothing but the radius, will give you the maximum value of shear. So it means if you want the plane of maximum shear, it is nothing but the radius parallel to y-axis. And my dear, at this, the state of stress is going to be sigma star comma tau max. Sometimes they ask you the question that what is the value of normal stress at plane of maximum shear. So my dear, the value of normal stress at plane of maximum shear is given as sigma star, which is sigma xx plus sigma yy by 2. And if someone asks you what is tau max, it is very easily written as the radius. You already have the two expressions of radius, one in terms of sigma, other in terms of xx and yy. So my dear, if you see, like in the last point also we have discussed that, if this point will give you the sigma 2 and this point will give you the sigma 1, then you already know that diameter is nothing but sigma 1 minus sigma 2. So if you want to write down the coordinate of center, you know that this distance is the radius. So if you want to write down sigma star, one more value can be written as sigma 2 plus radius. What is radius in terms of principal stresses? That is sigma 1 minus sigma 2 by 2. So you will get sigma star to be sigma 1 plus sigma 2 by 2. So from that you can say sigma xx plus sigma yy. This was the value of sigma star. Now sigma 1 plus sigma 2 by 2 is the value of sigma star. So it means, my dear, sigma xx plus sigma yy can be written as sigma 1 plus sigma 2. You know, xx and yy perpendicular to each other, 1 and 2 perpendicular to each other. So you can say that the normal stress, the algebraic sum of normal stress at two planes oriented at 90 degrees to each other is always going to be a constant value. So this is the beauty of Mohr circle, that it gives beyond the limit things. Okay. So I feel we have seen this. Now you get to know that this is going to be the plane of maximum shear. And this is already principal plane 1, this is principal plane 2. You can see the angle between maximum shear and principal plane is 90 degree. It means really the angle will be 45 degree. So if we have this direction for sigma 1 and this direction for sigma 2, because they are 90 degree to each other, then nobody can away from this that tau max plane will be lying at 45 degree to both. So this is how in 2 dimension you can represent all the 3 important planes. So guys, now we are talking about the wonderful plane of pure shear. They are something new. So my dear, plane of pure shear, what is the definition of pure shear? As the name suggests, only shear means pure shear. So the planes for which normal stress is 0 and shear stress is non-zero. It is like you say pure milk. Pure milk means in which water is not added. But for that milk should be there, na? So obviously those planes for which shear is non-zero, normal is 0, are said to be plane of pure shear. And such wonderful planes can be found out only on y-axis. Because on y-axis, x is 0, y is non-zero. So I will say except origin. because at origin both x and y will become 0. So we want shear to be non-zero at least. Otherwise, you are having the empty bowl and you are saying pure milk. It cannot be. For pure milk, milk should be there. So for pure shear, shear should be non-zero. So guys, these planes are not possible all the times. Like this Mohr circle, do not cut the y-axis. So here, plane of pure shear will not exist. So for that, it is compulsory that Mohr circle should cut the y-axis. Like in this case, Mohr circle is cutting the y-axis. So when it cuts the y-axis at this point and at this point, we will get plane of pure shear. So here normal stress is 0, shear stress is non-zero. So if you want to find out this, you already know this is radius and this value is tau star, and you already know this distance is sigma star. So by Pythagoras, when you know this is tau star, this is sigma star and this is radius, from Pythagoras we can write radius to be sigma star ka square plus tau star ka square. But we are interested in the shear stress on the plane of pure shear. So tau can be written as, tau star can be written as radius ka square minus sigma star ka square. That will give you the shear stress at the plane of pure shear. Now my dear, there is a one wonderful thing. If we have origin of the Mohr circle at the center, then you know from the center if we plot a radius, that gives us the plane of maximum shear. And Mohr circle where it cuts y-axis will give you plane of pure shear. So this is that beautiful condition when plane of maximum shear and plane of pure shear gets coincide with each other. So I am not saying they are always coexist. They are coinciding here if the center of Mohr circle is coming at the origin. So this is the beauty. So I can give you one thing, that plane of pure shear exists when Mohr circle cuts the y-axis at 2 points, or when principal stresses are of opposite nature. Means one principal stress is tensile, other will be compressive. So guys, this is the beautiful concept. Now we are moving to the last point, that is related to finding out the resultant stress. Like in this Mohr circle, you know this point is represented as sigma theta and tau theta. All the dimensions are measured from the origin. So you know that this distance will be sigma theta and this distance will be tau theta. So if I will make a triangle from the origin, then my dear resultant, this is the resultant. So you can see this is sigma theta, this is tau theta. So resultant can be found out how? Resultant can be found out by taking square root of sigma theta square plus tau theta square. And the angle made by this resultant is shown as phi. Phi is said to be angle of obliquity, and tangent phi is given as tau theta by sigma theta. This angle of obliquity is not having much importance for mechanical student, but it is becoming important for civil ones when they study geotech. So guys, I feel this should be the concept clarity of Mohr circle. And guys, in the upcoming sessions, in the practice sessions, we will also come up with the numericals on the same concept. I hope you guys are getting this. So do subscribe the channel for such wonderful concepts and high clarity, or you can say highly animated videos you will be getting on this channel. So stay tuned and goodbye for this session.